Hey everybody, in this video we'll talk about the topic finding a specified term of a geometric sequence given the first terms. But before we hop into this one, we're finding the 11th term, let's talk about another specific one that'll help us see where our formula is going to come from. If we were told to find the 21st term of this geometric sequence, okay, that would be a lot of multiplying by a certain number to get to the 21st term. Right? Now, say we were told to find the 100th term, that would be even more. So let's go ahead and see what's going on here. To get from -2 to 6, I multiply by 3. I do the same thing to get to each of my next term. So that means my common ratio r is equal to 3. Now keep that in mind as I show you the next portion of this. Our first term is -2 times 3 to the 0. I'm not multiplying by 3 yet. But my second term, I multiply by 3 one time. So that's 3 to the 1 power. So I take -2 and multiply it by 3 to the 1 power and I get -6. To get -18, I take my first term, -2, multiply by 3 to get to 6, and then I multiply by 3 again to get to -18. So that's like multiplying my first term by 3 squared. I continue this pattern. Okay. This, algebraically, this looks like this. Our first term is equal to our first term times our ratio to the 0 power. Our second term is equal to our first term times our ratio to our first power, etc. Right? Because we multiply by r multiple times to get to our next term. Now, as we continue on, we can make this equation for the nth term, no matter what the term is. We're going to take our first term and multiply by r raised to what power? Now, what is this power that we're raising r to? It is n minus 1. So this equation is an explicit formula for any term in a geometric sequence. So for any nth term, the nth term of the geometric sequence is a sub n equals the first term times our common ratio raised to the n minus 1 power. What is the a1? The a1 is our first term. The r is the common ratio. And then the n is the number of terms that we're working with. Okay, so keep that in mind as we work on this same problem. So here's our geometric sequence. We already determined that the common ratio r is equal to 3, and we're told to find the 21st term. So I'm going to use my formula for any nth term, which is a sub n equals the first term times the common ratio raised to the n minus 1. Where my n now is what? I'm trying to find the 21st term. So my n is 21. So I have my 21st term, or a sub 21, is equal to a1, which is -2, times my common ratio, which is 3, raised to the 21, right? That's n. 21 minus 1. So just again, where are these coming from? My 3 is my common ratio I found, and then my -2 is my a sub 1, because that is my first term. So there's all those pieces. So I'll get that my 21st term is equal to negative 2 times 3 raised to the 20th power. That is a big exponent, so we end up getting a really big number once we plug this in. We get negative 6,973,568,802. So we can see that geometric sequences, because we are multiplying, they get big really, really fast. Let's go ahead and work on this problem real quick. We have the sequence 7, 35, 175, and 875. This one might be one of those ones where r is a little harder to find. What am I multiplying by? To get from 7 to 35, I'm multiplying by 5. I could also take 35 and divide by 7 to find out what that is. So that means my first term is equal to 7. My r value is equal to 5. And then I want to find the 11th term. So in my equation, a sub n equals the first term times r to the n minus 1. N is going to equal 11. So I have a sub 11 equals the first term, or 7, times 5 raised to the 11 minus 1. So my 11th term is equal to 7 times 5 raised to the 10th power. That is also going to be a fairly big number. That is 68,359,375. So there is how you find a specified term in a geometric sequence given the first terms.